Hello everyone and welcome to this new video. In this series I will show you some interesting algorithms that oftentimes show up in these sort of coding challenges like Advent of Code. I really do love these challenges, and sometimes being able to write these algorithms from the top of your head in a very quick way is very important to perform well and to write simple code. Before starting, I also want to say that I am assuming that you are familiar with these fundamental programming topics. They will show up here in the screen somewhere. If you're not familiar with these, then please skip the video, or at least come back to the video later when you will have studied these things first. A quick disclaimer before starting the video. In a few days, this Everybody Codes story will be out. Everybody Codes is a challenge that takes place every year in November, and the author, while waiting for the main event, publishes these small side events, which are, as I said, are called stories. And they are basically sets of 3 problems which come out one every day, basically, starting in 12 days. And each problem, let's say quest, is composed of 3 sub-problems. And if you solve them quickly, you get to score, you get some points in the leaderboard, and you win the glory at the end of the quest if you are in the top 10, let's say. It's a very fun way to practice problem solving, and it's also very fun to compete with your friends and with other people online. And make sure to not use AI. These events are just for recreational purposes, and they are just fun to solve without using automated code generation. Okay, so let's jump to the problem itself. Today's problem is Advent of Code 2017 day 12. And I will gloss over the story here. You can read it if you want. It's sort of fun. The input that we're given is a graph. In this case, for example, node 0 is connected to node 2, node 1 is connected to node 1, and node 2 is connected obviously to node 0, since the connections are bidirectional, and is also connected to node 3 and 4, and so on and so forth. And what we are asked in this case is how many programs, programs means nodes, in the sort of lore of this problem, nodes are called programs. How many nodes are in the group that contains program ID 0? So how many nodes are connected to node 0 in this case? And the algorithm that is most useful in this case is DFS. DFS is a very common way to traverse graphs, and it is very efficient in this case because it's very quick to write. And for these simple problems, using DFS is much easier than using other exploration techniques like BFS, mainly because of its simplicity. Okay, so let's write the code to parse this input here. So what I do usually is this. So we are opening the file and splitting the lines. Now for lining data, what we can do is we can get the source and the destinations. So the source and dest is going to be line.split on this character on this sequence right here. And then we have to split the destination nodes as well. So dest is going to be dest.split, and we are splitting on comma space. Now if we print source dest, then we are going to get obviously we need to pass the input, and as you can see we parse the input correctly. In this case, I'm not converting to integers these nodes because it's unnecessary, because we don't have to do any numerical operation on these nodes. It's fine to have them stored as strings or characters. So what we're going to do is we're going to build our graph, which is a dictionary, and we're just going to say g of source is equal to dest. And then if we print g, then basically, as you can see, we have for each node a sequence of neighbors, and this is how generally you store graphs in Python. So now we are ready to explore the graph. So basically what we need to do is we need to count how many nodes are connected to node 0. So this is our question, right? So what we're going to do is we're going to define our exploration function, DFS, which takes a node and a graph. So for clarity, we can, this is just a string and this is a dict. So what we're going to do, so how does the DFS work? So the DFS basically, so as I said, we want to explore we want to explore the graph starting from node 0, and we want to count how many nodes we explore. So to count how many nodes we explore, we're going to use a set which is usually called visited, and we are going to place the nodes that we visit inside this set. And as you can see, I've written this as a global variable, so this will be seen from all the DFS calls. So the first thing we do is we actually do visited.add node, add n. So we first add that node to the visited set. Then we iterate through the neighbors. So for dest in g of n. So if we are not if we didn't visit that node already, so if that node is not in visited, then we can visit it. So we can call DFS on that node. So if dest not in visited, then we can DFS dest g. And that's it basically, okay? So that's the whole function basically. So if we didn't visit that already, then we start the DFS again from there. And at the end of this, so now let's go back here. What we can do is we can do DFS node 0 g, and then we can print len of visited to count how many nodes we were able to visit. And in this case, we are able to visit 6 nodes. This means that from node 0, we visited 6 nodes without repeating visits, so without repeating nodes. Let's test on the input. On the input, we have a problem because why do we have a problem with the input? Not enough values to unpack. That's weird. Maybe, okay, maybe I copied. Yeah, so another thing to be careful about in these challenges is make sure to copy your input correctly, otherwise things like this might happen. So as you can see, if I run this program on my input file, then I get the correct answer, which is 380. Okay, so for part 2, what we are asked is how many groups there are in total. So let's say that we have this graph right here. Okay, so I will draw bidirectional connection like this. Okay, so this is a graph that might resemble our input. Okay, something on these lines. So as you can see, not all the nodes are connected to each other. For example, if we look at the test input, we have that node 1 is disconnected from the rest of the graph. So it's like a standalone node. And we are asked how many groups we can identify in the input. So for example, in this particular example, we can identify 4 different groups. And these are also called connected components in algorithmic terms. So to count how many of them there are, a very simple thing that we can do is we can iterate on the nodes, start a DFS from a node, from that node if we haven't already visited that. And we can do that until the visited set is just full. So until we visited every possible node. Okay, so for part 2, what I did is I copied the first file, so a.py into b.py. Now we can edit b.py. And so let's get rid of this stuff. What we're going to do now is we want to count how many groups we have. So to do that, what we're gonna do is we are going to first do this. So we're going to get all of the keys of our graph and put them into a set. Now we iterate on the nodes, so 4 nodes in total. What we're gonna do is, first of all, we're gonna check if visited is equal to total, then we break. So if our visited set that our DFS fills, it's the same as the number of as the nodes in our graph, then it means that we visited every node. So we finished our exploration, so we can break. Otherwise, if node not in visited, we can start a DFS from node. So we can do DFS node G, and we can increase the counter by 1. And so we need a counter here. So counter is 0. And at the end of the day, we can print the counter. And that should be it. Yeah, so as you can see here, my answer is correct. So 181, 181. So how does this work? So if our node is not in visited, so if we haven't started the visit from there before, but that's impossible because we are iterating on nodes sequentially, or if a previous visit hasn't reached that node before, because maybe, let's say, when we're iterating on nodes, maybe we start from this. So this is not in the visited set. So when we call DFS on this, the visited set will be filled with all of this, because the DFS visits this connected component. Now, when we go to the next node, then we might end up on this. But this is already in the visited set because it has been visited from the previous DFS. So maybe the next is this. We will start a DFS from there and visit all of these, and so on and so forth. And in this case, our counter will be 4 at the end. And this is how it works, basically. Okay, so thank you for watching. This was the DFS algorithm explained hands-on in a very quick and efficient way. Make sure to follow the channel, put a like, and see you in the next videos.